The Clean Power Hour is brought to you by Continental Energy Solutions. I'm Tim Montague, co-host. Today on the Clean Power Hour, carbon sequestration of soil goes up when you put solar on ag lands. That's a story we're bringing you today by none other than John Weaver, written for PV Magazine. Got a couple other great stories. The ISS, the International Space Station, is getting a new solar array. We're going to talk about that. And Erthos, that's the name of a company, wants to put solar flat on the ground. I've often wondered about this, and now we're going to learn how it works. It could be a game changer. It could be a complete disaster, I suppose. GE says their new turbine could power the entire United States. I don't know if that's really news, because there is so much solar and wind and so much good news here on the Clean Power Hour. We are just swimming in energy. Welcome to the show, my co-host, John Weaver, the commercial solar guy.
Timothy, first off, thank you. It's great to see you, but I really want to point out that I think your haircut's great. You're nice and clean there. I bet you could totally put on a suit and tie and walk in and get a respectable job anywhere. So nice.
I'm a clean machine, creating the clean economy. What can I say? So, I'm really happy that you're active with PV Magazine again, John. We missed you when you took a short hiatus. So let's get right into it. You've got a great story here about agrovoltaics and multi-use, multi-benefit. What's the story? And I'll put that on screen while you kick that off.
So it's actually more than agrovoltaics. It's actually, this is about putting prairie grasses, natural deeper grasses that used to be very common across the Midwest before we pulled up most of it and went with modern ag. And so what this document does, it looks at the carbon sequestration properties of modern ag, and there are some. A certain volume of CO2 gets put into the soil. And then they look at solar plus turf grass, which is actually higher. And this was the cool part of this study, they looked at solar plus modern or prairie grasses, what used to be here. And because, prairie grass it's going to grow root systems that are 6-9 feet long. There's this picture out there on the internet of this recent research gentleman who has himself standing next to it, and I was reading about it, learning. And the thing is that we with solar, if our goal is to cut down on emissions, if we installed prairie grasses with our solar, we could draw 30% roughly equivalent more solar panels worth of emissions from the sky. So, there's some rough estimates here. So it's like install 10 gigs of solar in the Midwest, get 3 gigs free is the way I would sales pitch it to get everybody's attention. And then we'd have to delve into what that means, because the solar panels, they're offsetting a certain amount of coal, a certain amount of gas, these emissions things that we say. And so we're saying, hey, this is equal to 5,000 gigawatt hours. That's the number the researchers said. So they said if you installed 10 gigs of solar in the Midwest, and they got a map and they show the different states, you install 10 gigs of solar in the Midwest, you do it with prairie grass, you'll do 5,000 gigawatt hours worth of emissions getting sucked into the dirt. And if you do that for a long term, you're going to create a really healthy ecosystem. So it's a way of using solar to restore the natural habitats and calculating the environmental benefits of it. This is what's it called? And not an intangible, it's a externality. This is an externality that we should be allowed to put in our spreadsheets, to be blunt, sales pitch.
Yeah. This is a thing, and what most people don't realize is that carbon sequestration by soil is a huge potential sink, right? We need to suck carbon out of the atmosphere to get back to 350. We're at 400 and change now of ppms of CO2 in the air. And if we let soils be more natural and not farmed intensively using industrial ag practices, they are going to become a ginormous sponge in the ground. And as you rightly point out in your story, the Midwest was largely this vast swath of tall grass prairie or grasslands, right? And these ecosystems have root systems that are 10 feet deep. They're fire tolerant, and the plants stay alive through these raging prairie fires by living underground. And it's such a win-win, right? You're getting a solar farm, you're cleaning the grid, but then you're also going to get way more carbon sequestration if you plant your solar farm in native plants. Is that the gist?
That's right there, right there. Perfect.
Yeah.
So it's cool. And they gave a good number to it, which is, me, I like numbers. And so I could do a little math, and 10 gigawatts get 3 free for sale.
Yeah, I'm going to put these charts on screen because I want to talk about them as well. They're comparing pollinator supply index, carbon storage potential, sediment export, and water retention. And
those two are important as well. I because I was going for the headline number, but the water retention and the sediment loss were significant. The savings of sediment and savings of water retention. And there's a lot of research that shows solar in semi-arid climates can increase grasses that are grown for sheep, for grazers. And that research, it was all because of water retention. If we got water retention due to simply literally absorbing the sunlight and creating microclimates, and we're making the soil better, there's microclimate ecosystem change that we can push. And so thanks. I'm glad you said that, because obviously I'm excited about that particular image.
Yeah, it's very interesting to see how ag versus turf grass versus native grasses on basically all fronts here, right? You're going to get less runoff, less sedimentation with native grasses. You're going to get more water retention, but the carbon sequestration one alone probably is worth it, but you get all these other side benefits. So it's multi-use solar and multi-benefit solar, and I think that when the authorities having jurisdiction wake up to this, they're all going to want solar farms in their backyards, right? We don't like runoff here in the Midwest. We're always trying to keep water on the land because stormwater runoff creates a lot of problems. It creates the dead zone in the Gulf of Mexico, of course. That's the big kahuna. But the sedimentation is going to clog up the rivers and waterways. And so controlling the runoff on your solar site is a major thing. The ground is very flat here, but today it's ag, tomorrow it's solar farm, and guess what? There's going to be less runoff. So putting panels is not putting a building. And that's one of the challenges, John, is that some AHJs do look at a ground mount solar field and say, oh, you're developing this land. You're going to increase runoff from the land. So you got to work with the right civil engineers, right, who really understand the benefits of pollinator or native grasses, and it's a lovely thing.
I wonder if there's a value that can be gained by strategically placing solar that's not farmed amongst a farmed field. And, in this end, you put this kind of solar with this kind of grasses, so you get these types of bugs. You put these over there, or maybe you put them in the middle so you could get a little wetland, so the water will stay a little muddier. Something, I don't know. I don't know anything about farming. I grew up in suburban South Florida, but but I'm super interested in how we could potentially integrate large chunks, just 100 megs, 50 megs, 100 megs, and disperse it in, because these big solar plants, they always like to do 2.5 meg chunks, 5 meg chunks, because that's where the smallest inverters are. And then they go upward from that. So let's just say it's 5 megs. That's going to be, say, 3-4 acres. So if you could put 2 to 4 acres, no, wait, that's 10 acres, something like that. Little 10-acre chunks of solar plus natural grasses. Would that benefit the broader farm around it by having these sinks, these moisture sinks in the midst, birds in there? I don't know. That might not be good, but just wondered about that. So,
Yeah. The take home is that solar development is completely environmentally friendly. Yes, there is a carbon footprint to manufacturing the equipment, the steel, the copper, the aluminum, the solar panels, but the solar energy that the array produces is going to offset that within 2 years. And now, of course, we have a spectrum of ultra low carbon solar panels. So check that out, and we should probably move on. But thank you for such a wonderful story. Really, I love this story, and we're going to hear this drum being beat way more and way louder in the coming years.
yep.
Which is a good thing, because we need what we need 70 gigawatts of wind and solar a year, right? We need a lot of this form of development. It's going to be such a win-win for the environment, and ultimately saving our butts. The earth is going to be fine. We're not saving the earth, John. Did you know that?
Yes. Earth. Yes. The rock will do just fine.
Yes. The rock does not need us. All right. Well, the ISS also needs solar. The ISS is a microgrid floating in orbit around the Earth, and so they're getting an upgrade. What's the deal?
Okay, so if you scroll down just a little bit to like the first paragraph or second paragraph, they start technically getting into what they did. So let's see. So first off, this is a new rollout array. So it's a different product, I guess, than the prior panels, how it works. I read a little bit on the company, and at some point I saw somebody describing it as a product that was designed not for one-offs at the space station, for huge amounts of money, like $100 million, but to potentially be used in solar space industry. So they built this product to be mass produced, which is, means it won't cost $100 million to launch it. That's the whole thing. Yeah. So that machine on the right, I think it wraps in and rolls off. Oh, if you scroll down, look at that. Look how beautiful that is. First off,
that is amazing.
Yeah, dude. Oh,
so
man.
it literally rolls up, but are they using flexible cells, or are the cells still rigid? Do you know?
They're still flexible. This is flexible stuff. These are super thin vapor deposition type things that are sprayed down. They're multi-junction. I remember doing some reading on them. They're like, I don't know if they're Spectralab cells. They're like half cut, maybe. I've poked around in it a lot more, and it's pretty cool, the product that's being used there. And they're really efficient. They're getting, I think, 120 kW each. So maybe each one of those are a solar panel. If you scroll down, you can see an image right there on the right. They show the comparison in size. And I think it's an equal amount of energy. You just already went past it. It was it's really subtle. It's, you can kind of just see them right in between.
This is the new versus the old. They're getting they're getting their power from a much smaller array now.
Much.
And do you know how long it's been since they repowered the ISS?
15 years. I mean, I think these might be parts of the original ones, like the original array getting deployed, but I don't know that explicitly, but I think so.
This is a great example of how the march of technology advances, over time.
Absolutely. Like the best product on the planet that's so efficient, we still can't build it. We now have a smaller system. Still can't afford it on Earth. So
Yeah.
what's neat is that this might become a mass-produced product, and that is a significant thing, because if we start mass-producing stuff for space, space is cheaper, la-di-da-di-da. We all get to go to Mars for, a quick vacation once in our lives and totally get weirded out by the cold depths, darks of space.
Yeah, I think there's about to be a bunch more space stations and moon stations, et cetera, right? And they all need high-tech solar. And but what would be the application on Earth for expensive solar panels like this, do you think?
Oh, well,
Or is it
drones.
strictly that they're targeting space applications?
This company, yeah, they're targeting space. So drones, or I saw recently that they took this type of solar cell and placed it on top of other solar cells, maybe for emergency where you need the highest efficiency possible and you still need flexibility. We could probably deliver a shipping container full of these to some location and then pull out like 8 from one shipping container, roll them out on a building with a truck. Boom! Now you got a 600 kW power plant deployed by the U.S. military in 30 minutes. That type of weirdo stuff. That lots of rich people on vacation. We will camp here.
Yeah. Yeah.
Here's my
exactly.
120 kW power plant. Because I think each one of those units were 120 kW. So, you could put that on the back of your camper, dude.
Oh, yeah. Yeah, I think there'll be a lot of off-grid applications for these high-tech solar panels, and pretty cool. This is the other cool tech story here comes from Canary Media and your buddy Eric Wessoff. Erthos eliminates trackers in utility-scale solar. We saw that that Australian company is doing kind of the accordion style, right? Where they
Be electric. Yep.
Yeah,
Yep.
they manufacture the accordion in a factory and then they just roll it out, and it sits very low to the ground, but it's east-west. This is analogous. It's just that it's completely flat, and it's not pre-assembled, I don't think, in the factory. They're just doing it panel by panel. Although it does kind of look like there's a hinge there. I wonder.
That's probably for wiring or water management or something. Maybe they roll them out.
How do they get the water off this bad boy? A solar array, a flush mount solar array like this, this is typically what's going on a big slanted roof, right? Like residential or small commercial, you do flush mount. And now they're just taking that concept to the ground and saying, look, it's economical. At this latitude, I'm not sure what latitudes they're testing at. Do you know?
I know the company's based in Arizona, so at minimum they're talking in the southeast. They said one of their lines in this you'll see is they said around 38 cents a watt is where your solar panel cost efficiency equation says, yeah, make them flat. Who cares? And that's the model. It's like, yeah, we'll get over it.
And my concern, John, is that then you're not letting any light underneath the array, and it's a dead zone. Now, I did see some comments on the story that people are saying, well, just wait, the weeds will come. And so, there's
what about
many
bifacial panels. But weeds are okay, though. You're going to have robots that are going to be there to clean the panels and weed the panels.
Yeah.
That's not an issue. If you got something that's cutting what's it called? Picking up dirt, moving dirt off at the exact same time, it's going to go in between those rows. Now, the question is a tree going to grow up from underneath that thing? Because weeds and trees are, a tree can just lift up a whole little thing nice and slowly.
And they do have some credibility in that Jim Tyler, who's formerly the VP of Engineering, Procurement, and Construction, so the VP of EPC at First Solar, is now at the helm of Erthos. And First Solar, was a beast of a solar developer. Now they've split apart and sold their EPC arm, which is maybe why Jim was casting about for new opportunities. But pretty cool.
Yep. So floating wind.
So do you have a prediction in 5 years when we come back, will this technology exist still?
Will Erthos exist?
Well, or flat racking in general on ground mount. Do you think flat racking is going to be a thing?
Um, Flat ground mount. Uh, did I think that? Let's say this. I'll do just say out my mind because I don't have no idea. I'm terrible at picking companies, but I'll say this. Remember solar freaking roadways?
Yeah.
Everybody said that was a terrible idea. I liked it. Um, Solar freaking sidewalks, solar freaking parking lots, all that kind of stuff. I like it. I think that the cost of solar panels is going to go to a penny. It's going to be less than a penny. We're going to print out perovskites like there's no tomorrow from giant printing presses. And, at some point we'll be like, well, by law, you have to make extra electricity to power the space lasers that shoot our ships across the universe. And so everything's going to be covered with solar, because why would you waste photons, you fool? And, eventually we'll go that way. So yeah, there will be flat ground coverings. I think it'll be on the ocean, maybe. I don't know. I go so hardcore with the agrovoltaic that as being the solution to fight off the human nature of hating so much that it's interesting, because covering up the desert with a bunch of metal, creating impermeable surfaces, that's something that's going to get feedback from environmentalists aggressively and very negatively. And I think, I don't know, maybe use some bifacial solar panels. Maybe have little burrowing robots that create habitats for other animals underneath the solar panels, lizards and weirdo stuff. I don't know, but it seems like it's going to be a challenge. And smart people do stuff all the time, though, and they figure it out. I could see it happening in like the deserts of Australia, because they do all kinds of cool stuff. And there's a smart evolution, on commercial rooftops. We got east-west panels, like K2 Manufacturing. They make a good east-west. There's a company called BE Electric. I think they're a subsidiary of Jerkin from a German group, and they make the PEG racking system, PEG. And it's east-west, and it's literally on the ground. It's little sticks, and it floats east-west.
Yeah, it's like 3 feet off the ground.
Yeah, so we got an evolution. We got our flat systems on commercial rooftops, east-west. First off, we do 5-degree, 10-degree angles on commercial rooftops going south. Now we went east-west. Okay, now we're doing it on the ground east-west. Now we got that company, was it 5Q from Australia? I can't remember their name, but with that racking system that literally just goes ka-clunk, left, right. It's just like it's. So if we can get solar panels down to a dime, why the heck not? Why not get rid of all that metal? We'll chop down our material usage huge. Right now, all I hear in the headlines is that utility scale projects are getting pushed back maybe 15% because of the cost of steel. And array technology, their stock got whacked. And it got whacked because of the cost of steel. So you know what? At minimum, their press timing was wonderful, because everybody is stressed about the cost of the components that they highlighted in their article. And so, interesting.
Yep. Yeah, I'm not sure all the products that BE Electric makes. I'm looking at their website right now. I don't see that accordion style.
PEG. Type in PEG.
Yeah, so but PEG is different than the accordion. I mean, it's similar but different, right?
Yes, it's different. No, PEG is an accordion. PEG is just a ground mount rack that you can install with regular people with these little vertical poles.
Yeah.
And it's just east-west. Yep. Yeah, the accordion is like 5 something, the company name. They're from Australia.
Yeah. Gotcha.
So it's neat to see these different techniques for laying panels closer and closer to the ground at lower degrees, minimizing hardware requirements. I like the idea of a system being able to be installed by human beings in the 1 megawatt range. Like maybe for a private household, this is a great thing in the backyard. You have you could have like some grass, you can have some solar panels. It's not perfect, but it's good enough. Keep the kids off of it. Maybe the dog. Don't let the dog pee on it. Sorry.
You're cracking me up.
Hose it off.
So, China has developed a typhoon-proof offshore wind turbine. I'm going to put that on screen here in a moment. Um, I've 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 loved the concept of typhoon-proof anything, because these storms are real. They're getting more frequent. They're getting more ferocious, and so you absolutely have to figure out how to deal with typhoons and hurricanes. A typhoon and a hurricane are the same thing. They're just in different oceans, right? The typhoon is in the Pacific and the hurricane is in the Atlantic. Can
To
you
the best of
answer
my
me?
knowledge.
Can you answer me why on earth we have two different names for the same thing?
Nope.
I'm just joshing you. It's because we're crazy humans. So,
I just want to. I want you to share the pictures because those things were pretty cool. that was when I saw it. I was like, wow, that's neat.
yeah, my computer isn't cooperating. Here we go. So there's a mock-up, I think, and
No.
you
Scroll
see
down.
that.
Scroll down. We should have something. If I gave you the right link. Oh,
So there's this was a story within the story. Uh,
oh. There we go.
this is the main story. So
Yeah.
there's the this is the foundation that sits. It floats underwater. It looks like, right?
Yep.
And then it's anchored to some other anchors that are anchored to the ocean floor, presumably.
Yeah. So if you scroll up a little bit, I bet you on that link that you clicked too, you can see the ropes coming out of it on the right.
Yeah.
And so that's so they have different techniques, for lodging them to the ground, lodging different pieces to the ground.
Right.
And so that's what these guys are going to do.
So do you know what happens in a typhoon? Does anything change, or is it just that it's super stable and they just put it in stow position, so to speak, and
I don't know exactly,
or does it like sink or?
I'm certain that it rides the waves because that's how I've seen it for the one that's off the coast of Scotland. That's the High Wind project, and that's the first floating that I knew of. And I think that exists was that one up there, and it just rides the waves.
Okay.
So I just thought the pictures were cool, man. And there you go.
And it's a 5.5 megawatt turbine, which is not a ginormous turbine in these days. Right now they're coming in 12 or 13 megawatts, but I understand why they would make a smaller turbine for a high wind event.
And so them doing this reminded me of a press release from GE about a month ago, and that's that next click. And
okay.
First, they're developing 12 megawatt units for floating and they're specifically aiming to get into the floating offshore US market. And the headline that they used, or at least somewhere within the press release, they used a particular line that I thought was just important for us to have out there. It's that the market for where this particular unit would go would open up enough water depth, because it's not the 1,000-meter depth that that's within, say, 200 miles. It's like 60 to 500 or something like that. But it's a depth that if we were to deploy a whole bunch of floating wind, it alone could double the US electricity demand. So we use like 4 petawatt hours. It could generate, there you go. We use like 4,000 terawatt hours. It could generate 7,000 terawatt hours. And there it is. So depths beyond 60 meters of floating. Now I think it's like 60 up to 500 or 60 up to 1,000. And then there's 1,000. So it's just pointing out again and again and again, Timothy, that we have more than enough space to generate the energy we use. And we could double it with just the wind floating, just the floating wind, not the onshore wind, just the floating wind could double our nation's electricity needs, cover twice as much as we need.
Yeah. And we need more electricity. We are going to double or triple the grid when we electrify transportation and HVAC. And so, we definitely need to step on the gas with a technology like this, and it's a good thing. And the numbers are a little mind-boggling, but they're real.
Yes. 7,000 terawatt hours.
Yeah, that's a lot of juice.
I like wind stuff. There's all kinds of neat stuff that I have other headlines here. Like just like a month ago, White House announced that they were pushing to open up some Pacific Coast offshore wind. So this is the first bigger wind. I think one project's 3 gigs worth, another's 1.6 gigs worth. So I thought that was cool. And then some person has put in a plan to do pods, floating 10 gigawatt pods of floating wind off the coast of the UK, and they're between the UK and Iceland, and their goal is to take the power lines directly into data centers. So 10 gigs of solar feeding data centers along the coast of the UK, and I don't know, that just makes me science fictionally giddy for some reason. It's just like,
So why do they use the expression pod as opposed to like farm or park?
because there's going to be a whole bunch of little pods that are coming off the coast as if they're little spored arms, little wings coming off the coast of spinning, because they also want to do a giant power line like going out there. So maybe the pods are just little bubbles coming off this giant power line. I bet you it has to do the way it looks. Okay, so each pod is 1 gig. Sorry, pardon me. I had a extra 0 there. So it's 10 gigs total with 1 gig pods.
Mm-hmm. Okay. Full dispatch of the HIP offshore wind pods will be under the exclusive control of the UK. The UK's first captive wind farm in overseas territorial waters. Oh, interesting. Yeah. Yeah, it seems like the news about offshore wind just is accelerating. That's my impression. Like it's crossed a tipping point from a cost benefit perspective. Of course, offshore wind is more expensive, right? Because you've got to build these things and maintain them far offshore. But here we are.
But every
it.
project can be a gigawatt. and
Yeah.
And you don't have any neighbor issues. And now you can do floating. And it's like the biggest chunk of it, the biggest giant thing you had to put in the ground is now gone. So it's something. It's something
Yeah,
interesting.
now, but when it's floating, it still needs an anchor, right?
Yes. Yeah, it will get some sort of, I guess the word is mooring. I'm not sure. I'm not a professional there, but it will have some connections to the ground. I see these different versions of 1 wire going straight down, 3 wires in different directions. There's all these just different drawings of how to interconnect them to the ground and hold them in place.
Yeah. All right, moving on. There's a story here about EVs and EVs having lower maintenance costs, which is, when you think about it, just completely logical. But now there's some formal analysis here from the DOE Office of Energy Efficiency and Renewable Energy. What's the deal?
So first off, Consumer Reports put out a great document on this a while back, talking about the exact savings, and now we get to see from the Department of Energy with a really sweet chart. That's the coolest piece, but good numbers too, showing that the cost of running, for instance, a light duty, and we're focused on commercial, a light duty vehicle, certain cost per mile driven. And so it's here. So you have a standard van, 10 cents per mile. You got a electric, 6 cents, 40% lower cost of operation over its lifetime. Now, you then have to take that cost of operation per mile, let's just say let's say, how many miles do you think a van's going to go? 100,000 miles? Is that $40,000?
Sure.
So if your electric van is $40,000, if it's within $40,000, it's cool to buy. If it's $10,000 more, what the hell's wrong with you? And that's probably what it is. You know, what, like, for instance, a Model Y. What's the most comparable vehicle? Is it a $20,000 vehicle? Is it a 25, 35? You know, your car, what would you compare it against? You know, you have leather seats, so you have, it's at least, it's not premium, you know, it's not a big Mercedes, but what do you think its competitor costs? That's an ICE competitor.
An ICE competitor to the Model Y,
Yep.
it costs less. I mean,
Yeah.
unless it's a Mercedes. You know, maybe $10,000 less. Do you think?
Yeah. I was gonna say 30 grand. But I'll also tell you, I got a thing that my car drives itself, you know.
Did you get the beta yet, dude?
No. Cause you know why? Cause they got their video camera looking at me and they know as soon as they give me beta, I'm gonna be looking at my phone, I'm gonna be goofing off, I'm gonna be working. They just know. They're like, this guy's a fool. We can't put it out in his car until until this thing is ready for babies. Man.
You know, I have to say I do hate it when I'm in robo driving, right? You're in auto steer on the highway, and if you don't keep if you're not real careful keeping the robot happy, right? It'll shut off, and then it won't let you use it again until you park. So yeah, you gotta pay attention to the robot. I told my friends recently, I'm now the pet of my car. It's not vice versa. I'm the pet.
So I don't have as much issue making the robot happy, but what does happen is that I'll be cruising and just staring. I'm good at keeping my hands on the robot and just putting my hands up there and letting them rest. But I'm like staring, and the car's in the right lane, and then the car gets off the highway, and I'm like, oh, because the car is getting off the highway, it'll do the first lane exit on its own. That's the way my settings are set up. It doesn't normally change lanes on its own. It can, it has that ability, but I turn all that stuff off because I'm scared. But when it gets off the highway and I'm not paying attention, then I'm just like, oh, that was fun. And, it just does something to me. And it makes me happy. Like the other day, it was super rainy and I couldn't see something really well. And it totally moved better than I would have. I would have been closer to something that I didn't want to. There was a split in the highway and I couldn't see where the split was beginning. And it was just, good lighting for that kind of stuff. And the car's like, boom. And I was like, oh, wonderful. I don't think I would have hit anything, but I would have been way more closer than I should have been. So smart car.
I think it's going to be longer before we have full autonomy than we think, and it's telling how slow the rollout of the beta is going. I'm still hopeful, but
I also heard that they're moving to a new visual only system, and you're gonna have to be really conscious of relearning how this vehicle drives. So there's that.
How so?
Well, radar, some say, radar was still being used on our cars. My car has radar.
Yeah.
And Musk recently said the reason we have radar is because it can do things that visually we can't. Radar is the crutch. And it's like, okay. But now the new versions of the car aren't coming with radar. And secondly, I think our cars may cease using the radar as the software goes to pure visual, because I think we have the cameras to do it. So there may be an evolution, and there will be a change in how the car views the road, which means how the car drives. And I've heard some people be fine with it. I have seen some people complain about certain nuances. You know how we complain about things. It's like, well, when we're driving over 3 humps and it's Tuesday afternoon, then this happens. It's like, okay, cool. Things do happen. Yes, we're driving and we have cars that are robots. We know that they're going to be weirdo things, but so just there will be some learning curve to occur is the best to take from that.
Yeah, cool. Well, let's talk about a solar beehive. I don't know why you would need electricity in your beehive. Um, you have any thoughts about that? It's a cool picture.
Oh, well, actually, so I don't know exactly why this one has the beehives, but there's other things that manage temperature and can kill the bugs, and cool beehives generate more energy. So,
More honey, you mean?
more honey, yes, yes. But there's also mites. So there's this angle of
Yeah.
getting bees to a certain angle and mites to a certain angle, and so as one of the articles I read, and there it is, I just clicked on it, says that between 42 and 50 degrees is this good temperature range. So the mites cannot cope above 42, while the honeybees can get up to 50. So you want to get to like 43, somewhere within that window. And so it's all kinds of little.
Kill the mites, but keep the bees happy, right?
Yeah, I just thought it was cool, But yes, kill the mites, keep the bees happy, and maybe you could have solar powered beehives next to pollinator friendly solar power plants.
Absolutely. All right. Well, we're going to talk about a spinning source of energy. We've not talked about this before, I don't think, but
It wasn't in the
well,
news, just to let you know. There's no whiz
okay.
bang. One of
What's
my
but spell it out for us. What is the technology?
it's a flywheel. It's you slowly spin up a chunk of thing, rocks, metal, very finely laid out, and some of them float on electromagnetic beds. And so once you get it spinning, that spinning mass can be used. At minimum, it can be used to generate a frequency to help form the grid, because that's fundamentally what the big spinning masses of coal and gas and stuff like that are, just big chunks of metal going real fast. And
Yeah.
and so one of my sales guys, he was just looking at it, and he's like, we should look at flywheels. I'm like, all right. So we all found some links, and I messaged him, and then I saw their spec page. I thought it was cool, and they had some data on spin time and the amount of energy. And if you scroll down a little bit, they show some of that juice. I think it was a 8 kW unit, and it's 32 kilowatt hours. It's at 4 hours at 8 kW. Yeah, there it is, right there. And I just thought that was cool.
Yeah, we've taken a look at flywheels a couple of times, and we haven't been able to make it pencil. But why not? In theory, it is like a battery, and Amber is claiming that they have lower O&M costs than a battery. I find that very hard to believe, but okay. You got these moving parts. That means things are going to wear out unless they're truly floating electromagnetically, which would be awesome if they can do that, where there's no metal on metal. That would be amazing. I guess in theory it's possible. Is that the case here? Is this floating?
I don't know, actually. I didn't even hear the floating thing until after I was speaking with other people about it, and
Yeah.
I never looked that one up. I just kept reading other stuff. I sent them an email because on their website they said it's a price competitive piece of hardware, and that's really what I was hoping to find out, because I have no idea what these cost. My default reaction was, yeah, it's not going to work. So but since I want to do my best to learn and try and figure things out, I started to research it, read it a little bit, and it's just it's a big chunk of metal that spins, and that makes it makes certain sense. I mean, it's how we power our power grid right now. So
Yeah. Well, when it mentioned microgrids in this spec sheet, so that jogged a memory for me, and that is that I recently tuned into the Emerge Alliance. Have you heard of it?
Nope, nope.
So I'm going to put this on screen. Here's their website, emergealliance.org, and they are a standards organization creating standards for microgrids. And the lab in Albuquerque, what is that called? Sandia Labs is heavily involved. I didn't know this. Sandia Labs is the largest of the national labs. And I grew up in Albuquerque, as you know, so I had friends whose dads worked there. But anyway, I sat in on a call on this particular subgroup called Campus Neighborhood Community Microgrids. And there was a fellow from Block Energy giving a talk. And I'm in love with this stuff because, as I mentioned about 10 episodes ago, the day is coming when microgrids will be required everywhere, right? At the home and the neighborhood level. It just makes perfect sense. And now so the technology is maturing, and this Emerge Alliance is very focused on the standards. So power to them. Glad they're doing it. Look forward to getting them on the Solar Podcast sometime and really breaking this down. I think that was the guy, Gary Opadahl. Maybe it wasn't Block Energy. Anyway, microgrids are the future, John. Just like the ISS, right? That technology today, the solar array, the batteries that they have, super expensive, but super robust and super productive, super efficient. That technology is going to come down to earth, and we all want it because power outages kill, and they make us very uncomfortable. I don't like being uncomfortable. I like my AC. I like my heat.
I like my heat more than the AC. AC's okay. I guess I live up north though, on the ocean. So not everybody lives on a nice cooling ocean.
I think it would be better to freeze to death than to burn to death, but I'm kind of with you. Being cold for an extended period of time is rough. Being hot, you can always put water on you to, jump in the pool, jump in the lake. If you're cold,
Take a nice long shower.
And if you're cold and you don't have heat, you got to do jumping jacks. Should we do one more?
Sure. You want to do robots or energy storage?
Let's do robots.
It's just two robots. One of them, it's for the offshore wind business. And the purpose of this specific robot was to autonomously map offshore cable routes. And before they were using ships, much more complex, much more expensive. And so now they have a couple of little guys, you can see right there, who will map cable areas.
Looks like they're solar powered.
Yes, they are. Well, I think they look like they are.
Yeah.
So
these are mapping the ocean floor for offshore wind.
yeah, they're looking very specifically for the cabling coming from the wind turbines going into each other and then into the coast, so they can figure out where to land, because it's, you want flat land, you don't want to put it over rocks, you want to kind of just be conscious of how you lay that stuff out. Apparently, I'm learning.
They turned the SUV on its head. It's the USV by X-Ocean, the unmanned
Something
what's
vehicle.
the S for?
I don't know. You got to scroll up, find out. Got to read the article, Tim. Come on.
Surface. The USV, unmanned surface vehicle.
Uncrewed surface vessel.
I like it.
And it's surface of the ocean, which is neat. So
And then you had a related story,
Oh yeah,
or
just another robot. So this one's a solar pile driver, and if you notice the unit, it's pile driver, but it moves on its own, and it just kind of goes from little spot to spot. You got to have the unit placed. It's GPS. What you do is plug in probably, I don't know exactly because I don't know this unit, but you probably plug in the CAD file, and then the CAD file, and you maybe set a starting point, and then you go from there. And it just kind of, and you guys probably use hardware like this, so this is probably not that cool to you, but I think it's cool because
I've never actually seen one that is completely GPS driven. There's the this is cool because the workers can really focus on the pile and not be tweaking the machine so much.
it looks
And
like there's a string there, so maybe the machine and maybe there's more than just GPS. Maybe the string is for the pile as the workers place the pile.
yeah, well, it's good to know. You pull a string so that you know you're following that straight line. You don't want the piles to get out of line.
Yep. Yeah, I mean,
And
the string probably gets the human and the pile to roughly the right place. And then they feed it to the machine, and the machine just goes wiggle, wiggle, wiggle. And this is where the unit's going. But who knows? I just think it's cool. We got robots doing work, and robots doing work with good data. I saw at the conference, a company talked about on the show, drones doing building scans that output to high quality CAD files. I haven't used it yet, but eventually, maybe. I think it's cool stuff.
definitely love the use of drones and solar. Well, John, let's wrap it up. How can our listeners reach you?
Go to Google, type in commercial solar guy. I got a Twitter account. I like to share lots of nerdy stuff. My website, if you like news, I do news. I haven't been doing as much news because I've been writing more for PV Magazine and work's been busy. But I do a news tab. I'm on LinkedIn, always trying to share something useful and say something that's not goofy. That one's challenging. Hey, so I got a prediction. You heard it here first. The month of May, the United States got really close, or maybe even touched 50% of our electricity from renewables. So I'm publishing that article as soon as I can get focused and write. I'm just so busy. And plus I do a site visit in the morning, mess it up. So that's how you can find me. Sorry. And Tim, how can our listeners find you?
Just go to cesenergy.com, those 6 letters, go to the podcast tab, subscribe. Please subscribe to the channel on YouTube. And you can also get the Clean Power Hour on your favorite podcasting platform, whether that's Spotify or Apple Podcasts or Google Podcasts. Give it a thumbs up, give it a rating, share it with your friends, make comments. We love to hear from our listeners. That's the way we know we're making an impact or pissing you off. But we sincerely want to hear from you. So please reach out to us. You can also reach me on Twitter at TG Montague on Twitter. And here's the Clean Power Hours on that landing page. So check it out, cesenergy.com/podcast. Well, thank you, John, for another wonderful episode. I say let's grow solar and flywheels.